matter is not prior to consciousness. And I think a key reason why I take that point of view is that high energy theoretical physics tells us that space-time is not fundamental. It has no meaning beyond the Planck scale, 10 to the minus 33 centimeters and 10 to the minus 43 seconds. It just fails to have any meaning at all at that point, no operational meaning. And so space-time cannot be fundamental. And high-energy theoretical physicists are already now looking beyond space-time. They're trying to find deeper structures beyond space-time. So they have the ERC, the European Research Council, has a 10 million euro initiative bringing together mathematicians and physicists to find what they call positive geometries outside of space-time that don't care about space.
For anybody that wouldn't be familiar what positive geometries might be or look like, can you maybe just elaborate a bit on, what we're actually talking about here?
Right. So incredibly, in the last couple decades, physicists have known for a long time that space-time can't be fundamental. That's not news. And they've known that Planck scale, it falls apart. The question is, how do you go beyond space-time, right? How do we think outside of space-time? What do we do? And what they discovered was there are these geometric objects. It's almost like monoliths or, diamonds or something like that, outside of space-time. So they're geometric structures whose volumes and surface structure and edge structure does encode interesting things about particle interactions, the probability of interactions, and the kinds of interactions they can have inside space-time. It's magical. But so there's something called the amplituhedron, associahedron, cosmological polytopes, and so forth. There are a number of these that have been discovered, and magically these things allow you to compute the probabilities of particle interactions inside space-time. And in fact, in many cases, you can do it much more quickly and much more easily than in space-time. The computations are much, much simpler. And so there's a big initiative now, just in the last couple of years that got started with the ERC, saying, there's some gold outside of space-time. We know that space-time isn't fundamental. And so we're taking our first steps outside of space-time. And what do we see? We see these monoliths. It's much like, 2001: A Space Odyssey, where the apes are, there's this monolith that's come down and they're pounding on it and wondering what this thing means. We know it means something really important, but we don't know what it is. We don't have any dynamical systems outside of space-time yet. Just these monoliths that are sitting out there that have all this stuff. So that's one reason why I don't think consciousness is derived from space-time and objects, is because our best physics tells us that space-time and objects are not fundamental. And my own take is that physical objects don't even exist when they're not perceived. So, to be very, very clear, right now I don't have any neurons. If you looked inside my head, you would find neurons because on the fly, you create what you see inside space-time. But space-time itself is not fundamental.
Okay, I'm joined here with Dr. Iain McGilchrist and Professor Donald Hoffman. To get started, guys, can you maybe just both give us your definitions and understanding of consciousness? We can start with Iain here and then move to Donald.
Well, I think almost by definition, you cannot define consciousness because it's not properly boundaried and comparable with anything else that exists. It is the ground of everything that we know. So it's almost like asking a fish to describe water. And it's that without which we would not be able to have experience. I think that's the first thing. And of course, there are many meanings of the word consciousness, and they can sometimes cause difficulty because people slip between one and another. So, a fairly basic distinction to make is between the consciousness that you lose when you are under an anesthetic, or even when you're dead. The consciousness that you have lost, and the distinction between things of which we are conscious in day-to-day experience, and there are an enormous amount of what we undergo and experience that we're not aware of. So there is a sort of self-aware kind of consciousness, and there's just the consciousness that is, if you like, tacitly taking in experience, and that's by far bigger than our consciousness of which we are aware.
Interesting. Okay, and Donald.
Very good. I agree with Iain completely. I guess the only thing I would add is that in the context of scientists who are trying to understand consciousness, I would like to also emphasize that for me, a science that tries to understand consciousness needs to explain specific conscious experiences. It's not enough to hand wave about being aware or not, or conscious or not. I don't think you have something on the table of interest until you have something that says, this is my explanation for the taste of mint or the smell of chocolate or whatever. In other words, if I were a particle, if I came to you and said, I've got a brand new theory of particle physics, brand new, and you say, oh, great. Okay, so what particle interactions can you explain? Like quark-gluon interactions, or photon electron. What can you do? And I say, oh, no, I can't explain any specific particle interaction. I just have a general theory of particle interactions. I would say, come back to me when you have something interesting to say about specific interactions. Until then, what's the theory of particle interactions that can't explain a single particle interaction? And so that's the point I would like to make about conscious experiences. If some scientist says, I can give you a physicalist theory of conscious experiences, then I say, oh, great, no one forces you to do that. But if you say you can do that, tell me which specific conscious experience you can explain precisely. Until then, I'm not terribly interested. So that's the only other thing I would add about conscious experiences, is that it's easy to sort of wave your hands and be airy-fairy. I say, give me one, a specific experience. Now, I agree with everything else that Iain is saying about this. I agree that that's all important. But when we do, when it comes to someone claiming they have a scientific theory, then I want something real on a particular experience. So,
well, I would agree with that as well.
I don't doubt. Yeah, I don't doubt. Exactly.
Okay. So can I assume that both of you would agree that matter comes out of consciousness rather than the other way around? And curious to ask you both, what would you say is the most compelling evidence for this? And also, why is this important for us to understand? Like, why is this an idea that needs to be taken seriously in the culture? And we can start with Donald this time and then move to Iain. Just change it up a bit.
Yeah, I think we both agree. Well, I'll speak for myself, though, that matter is not prior to consciousness. And I think a key reason why I take that point of view is that high energy theoretical physics tells us that space-time is not fundamental. It has no meaning beyond the Planck scale, 10 to the minus 33 centimeters and 10 to the minus 43 seconds. It just fails to have any meaning at all at that point, no operational meaning. And so space-time cannot be fundamental. And high-energy theoretical physicists are already now looking beyond space-time. They're trying to find deeper structures beyond space-time. So they have the ERC, the European Research Council, has a 10 million euro initiative bringing together mathematicians and physicists to find what they call positive geometries outside of space-time that don't care about space-time. They don't care about quantum theory. They don't care about unitarity. And what they're trying to do is understand these geometries that couldn't care less about space-time, but nevertheless allow them to predict scattering amplitudes for particle interactions inside space-time.
For Don, for anybody that wouldn't be familiar what positive geometries might be or look like, could you maybe just elaborate a bit on what we're actually talking about here?
Right. So incredibly, in the last couple decades, physicists have known for a long time that space-time can't be fundamental. That's not news. And they've known that Planck scale, it falls apart. The question is, how do you go beyond space-time, right? How do we think outside of space-time? What do we do? And what they discovered was there are these geometric objects. It's almost like monoliths or diamonds or something like that, outside of space-time. So they're geometric structures whose volumes and surface structure and edge structure does encode interesting things about particle interactions, the probability of interactions, and the kinds of interactions they can have inside space-time. It's magical. But so there's something called the amplituhedron, associahedron, cosmological polytopes, and so forth. There are a number of these that have been discovered, and magically these things allow you to compute the probabilities of particle interactions inside space-time. And in fact, in many cases, you can do it much more quickly and much more easily than in space-time. The computations are much, much simpler. And so there's a big initiative now, just in the last couple of years that got started with the ERC, saying, there's some gold outside of space-time. We know that space-time isn't fundamental. And so we're taking our first steps outside of space-time. And what do we see? We see these monoliths. It's much like, 2001: A Space Odyssey, where the apes are, there's this monolith that's come down and they're pounding on it and wondering what this thing means. We know it means something really important, but we don't know what it is. We don't have any dynamical systems outside of space-time yet. Just these monoliths that are sitting out there that have all this stuff. So that's one reason why I don't think consciousness is derived from space-time and objects, is because our best physics tells us that space-time and objects are not fundamental. And my own take is that physical objects don't even exist when they're not perceived. So, to be very, very clear, right now I don't have any neurons. If you looked inside my head, you would find neurons, because you on the fly, you create what you see inside space-time. But space-time itself is not fundamental. So maybe there I'll pick a fight with Iain. I don't know, but maybe not.
Well, shall I say something at this point now?
Please jump in. Go ahead.
Yes. Yeah, I think we've got the basis here for a nice disagreement. Gosh, where to begin? The first thing is that it's not true that all physicists think that space-time, and particularly time, is not fundamental. The great Lee Smolin, for example, thinks, as I do, that time is fundamental. I make a distinction between space and time in this way. I think time is more fundamental. And I don't think that we can conceive of anything in reality that had no time to it. What seems to me to have happened here is that we've gone off into a sort of Platonic realm of abstractions of geometry and, as you mentioned, geometry and algebra and all these things that do exist outside of space-time. But they're only there when they're not manifest in the real world, if you see what I mean. They're always there in a cupboard waiting to be consulted, but they're not what we mean by space and time, and of course the terms are human terms, are the things that make it possible for us to differentiate any one thing from any other thing. Without space and without time, that differentiation, which is fundamental to all experience, would not be possible. So I don't take that view, and I'm not sure that I think that hemispheres will come in here, sorry to say, quite a bit, because I think there is a distinction between the world of the left hemisphere, which is abstract and internally consistent, but actually doesn't matter. The left hemisphere doesn't really care whether it matches up to reality, as long as it's internally consistent in a theoretical sense. Whereas the right hemisphere is empirical, if you like. It has a window in its cell. The left hemisphere is a bit like that padded cell, which I may be misunderstanding you, but I take it from your frequent references to reading off from dials and so on, that one's actually there's a barrier between us and reality, and one's at a complete remove. Whereas I think that is exactly how the left hemisphere sees things, but the right hemisphere is very interested in testing things against experience. So there's that. But to come on to other reasons for thinking that matter is not, that consciousness is not derived from matter. I mean, I think that here we might agree is that despite this being debated for hundreds of years, nobody has come up with an even remotely plausible explanation of how you can have any amount of matter you like, connected in any way you like. If it has nothing to do with consciousness, you'll never get consciousness out of it. So consciousness must be there from the start. And I think that is a view that a lot of contemporary scientists, physicists, and philosophers take. And it also has the advantage of being a position held in many of the wisdom traditions around the world, that consciousness is an ontological primitive. My view is that it's not that one or other of them comes first. So although I don't think matter came first and consciousness came out of it, I don't really think that consciousness came first and matter came out of it. I see matter as a way of manifesting itself that consciousness takes on. So consciousness can be something that is very airy-fairy and hard to pin down. It has no persistence. It offers no resistance to wherever my fantasy wants to go. But for very good reasons, because the cosmos is essentially creative. For the reasons that nothing can be created without a degree of resistance and a degree of persistence, consciousness takes on another form, which is that of the material. Now, nobody has ever seen matter. All we've ever seen is aspects of our experience that we like to call material. And what we mean by that is that they provide resistance and persistence. So in this sense, I think matter is a phase of consciousness in the same way that ice and water vapor are phases of what we normally think of as just water.
I think we're very largely on the same page. But I'll try to pick on where I think there are differences. So on the time thing, at least Mullen does think that time is fundamental. So he is a physicist who thinks that. Most physicists like Nima Kani-Hamed and others point out that time ceases to have any meaning operationally at 10 to the minus 43 seconds. And so there may be some notion of sequence, but the space-time notion of time just has no operational meaning. So, but these physicists would say is that if you can't give me any operational meaning to the thing, in some sense, we just have to move on. So if you want to talk at time, at 10 to the minus 50 seconds, then it doesn't work. There's nothing you can say. There's no experiment that you can do to talk about time at that level. So the physicists, I guess, just disagree on this point right now.
They would do, and they disagree on most points, I find, in a very healthy way. But I think that two things I'd say, that if you still want a sequence, you've got to have time. And the other is that once you get down to the minimum that we can know, the Planck length, are you not, by definition, stopping time? I mean, because you've actually gone to the point where time no longer moves for us. But I don't think you've abolished time as a concept. You've just taken, it's rather like if I had a living creature and I took it to within 1% of being dead, but it was still alive. And I'd say it's got none of the qualities of a living being anymore, but it is actually alive. So I don't think that, perhaps not a perfect example, but it's one that comes off the top of my head. But what I'm really saying is that the fact that you can provide circumstances in which time will not manifest itself is not to say that time is not real, I would argue.
Well, and I guess this gets to the nature of our theories more generally in science, right? So that might be a more background position to look at for this kind of discussion. My own take is that no scientific theory, in fact, no verbal theory, has infinite scope. So that every theory starts off with certain kinds of assumptions, and if you ask, please grant me these assumptions. And if you grant me these assumptions, then there's this realm of explanation. I can use these assumptions to explain this stuff, but of course it's not infinite, and there will always be limits. For one thing, you don't explain your own assumptions, and so we start off in our typical space-time theories. We start off with the assumptions of space and time. We say, grant me these, and Einstein assumes that the speed of light is the same in all reference frames, and all reference frames have the same laws of physics. And if you grant him that, then you get Minkowski space and eventually general relativity gives us and so forth. But you have to grant those assumptions. And Einstein spent his whole life trying to figure out what light was and didn't know, but at the end of his life what light was. And yet that was a foundational assumption for building his wonderful theories. And so I think that any of our concepts, so not just space and time, but any of our concepts have necessarily limited scope. And I think of scientific theories then as in a couple classes. There are just bad theories that are not interesting. And then there are good theories that give you mathematical tools to explore their scope, because they do have some scope, but nothing has universal scope. But they do have some scope, and so they give you the mathematical tools to explore their scope. And then a great theory, or a great package of theories, gives you the tools not only to rigorously explore their scope, but also to show you the very limits of their explanation. We know a priori that there's no theory of everything in the sense of a theory that has the ability to explain all of reality, period. I mean, there's a technical sense of theory of everything that physicists use where they're talking about some specific models in physics that they're trying to bring together, but they're not talking about a theory of the all of reality, just a technical term. So what I would just say here is that ultimately, in the big picture, any of our terms have limited scope, and a great theory will say, for these terms, here is the limit of scope of those terms. And for at least the way that time and space are used by current physics, that limit is the Planck scale. And now we could have some deeper notion of sequence that we might want to call time, but it'll be different than the time that's current in space-time theories.
And could you both just share the foundational assumptions that your theories are built upon from the ground up? So Don, can you share yours? And then Iain, if you wouldn't mind sharing yours too?
Okay, yeah. So my theory is pretty radical. So I'm starting outside of space-time. I'm saying that has limited scope. And so I'll have to have, and I want to have some notion in which conscious experiences are fundamental. Things like the taste of mint, the smell of chocolate, and so forth are fundamental. And so as a hard-nosed scientist, then I need to give the same hard-nosed attitude toward my own theory that I just gave a minute ago to physicalism, right? So with physicalist theories of consciousness, I'm very hard-nosed saying, okay, you claim to have a physical theory of conscious experience. Great, give me one. Give me a specific, mint. How does mint arise from neural activity? No hand wave. I want a specific theory. So it's a take no prisoners kind of approach. Do it, give it to me or not. And I have the same view about those like me who say that conscious experiences are fundamental. There, the turnabout is fair play, and my attitude is someone who wants to be a scientist, wants to have a rigorous theory and says consciousness is fundamental, they better give me a theory that starts with a rigorous representation of what they mean by conscious experiences, and they better give me back Minkowski space, they better give me back general relativity, quantum field theory. No hand wave. I mean, I want the entire thing, every bit of it, or you're not in the game. You may be getting preparation for a scientific theory of consciousness, but you don't have one until you give me Minkowski space and general relativity and quantum field theory. When you can do that, it doesn't mean that you're right, but it means at least you're now playing the scientific game here. So of course, science has a lot of phases. Sometimes we have to just work through the ideas and the phenomenology and get intuitions, and that's perfectly fine. But to claim we have a scientific theory of consciousness that has a high standard. Now you better give me general relativity and quantum field theory, or you've overspoken. So what I'm working on right now is a mathematical model that I call conscious agents, and the technical thing that we're working on, this is with Chetan Prakash, who I've worked with since 1984. So we've been at this we're persistent. We've been at it for quite a while. We've discovered we model conscious experiences as simply as possible now. We just say you have a bunch of experiences, taste of mint, smell of garlic, so forth, and there's probabilistic relationships among them. So what's the probability if I have this experience now that I'll have that experience next? And we write it down. I mean, that's sort of the minimal that you could do to talk about conscious experience. There are experiences and some probability that you'll have different experiences that, in sequence. And so you can use Markov matrices to describe this stuff. And so we do. So you can look at the space of all possible experiences as an infinite number of sets of conscious experiences. So there's an infinite collection of Markov matrices that could model all possible experiences and experiencers. We can just call them observers. And what we've discovered is a new mathematical fact about Markov matrices that wasn't known. There's a logic that unites all these matrices. And so we call it the trace logic. And if you want, we can go into, I'll just say that if we want to go into it, we can go into it, but I'll just say that there's a logic that tells you how to take conscious observers and take their unions, their intersections and implication and negation and so forth. So there's a logic, the mathematical logic. And what we're doing now, I have a first proof of how to build Minkowski space from this mathematical logic of observers and getting the time dilation, space contraction, and so forth. So what we're up to right now is starting with a very, very simple model of consciousness, what we call conscious agents and conscious observers, and showing that without hand wave, you can get Minkowski space, and then going after quantum field theory and general relativity. So that's my goal. And again, I'll just say, my theory, like any scientific theory, if it's a theory at all, will have some limited scope. It won't be the final theory of everything, but at least if I can show how I get Minkowski space and general relativity and quantum field theory, at least I'm on the playing field. At least there's a theory that we can now go and try to find its limits. So that's what I'm up to.
Interesting. Okay. And Iain, same question to you.
Yes, well, I guess I'm not trying to find a theory of reality. In fact, I think there's a problem with the whole concept of, and it's something that perhaps Donald and I could come on to talk about, that what do you prioritize as real is what reality would look like if nobody was looking at it. It is something unsearchable and unknowable. And so everything that we know is real comes out of an encounter. So I believe various things. I'm a process philosopher in the tradition of Whitehead. I believe also that everything comes out of relation. So there is nothing tout court that just exists. There are only things that emerge from a web of relations. And everything that we know, each one of us, comes out of a sort of unending series of encounters with whatever it is that is not just made up by my mind. Because I hold that my mind does make things up, and there is also a reality that is quite independent of that, but that each of us sees, experiences a slightly different reality. But this doesn't mean that it's a free-for-all and anything goes and anything can be real. Not at all. There is enormous consistency between the experiences that we report. And you can't get round the problem, the sort of the Humean problem, that when I say something is red, do I actually see the same color you say when I see red? We will agree on the terms, but we may not agree in experience. There is no answer to that one, I think, except to say that why... there is such a thing as doubting too much. And the one thing that some philosophers do is doubt everything except their own doubting. And sometimes, it's very important to doubt your doubt. And in other words, to moderate. You're always holding an equilibrium, it seems to me, in going through the business of living, in which you're holding together two things that pull in different directions. And I don't want to go back into everything I've said about Heraclitus and the coming together of opposites, the so-called coincidentia oppositorum, which I think are absolutely essential to existence. But I think that we are in need of, there is a toing and froing in this relationship, and often there is a coming together which reverberates, and in the reverberative process gets closer to something. And then there are the relationships between my reverberative experience and your reverberative experience and all the other relations. So I think that whatever is real is built out of an enormous bed of relations. I can't put it any more clearly than that, I'm afraid. And I also am a little skeptical of the idea that before, I mean, it is obviously true in a certain sense that before you can discuss something, you need to agree with the other person what it is we're talking about. But I do also think that I'm a bit suspicious of the idea, which is an Anglo-American analytical idea, that you must say at the outset of your search, of your venture, of your journey, what it is you mean by something, because you won't really know that until you've done the journey. And so what you need to do is to have a concept which is not entirely rigid, but which is in the area, and that it comes into being not like the image is not one of building a wall brick upon brick and then finally you've got the wall, but it's more of a picture coming into focus. So it's not just a linear thing and then you get it. It's that the whole thing needs to create a gestalt which has meaning, and that's an image of what I think is going on when I look at different people's experiences. Now, behind my belief that the hemispheres subtend different kinds of world is simply a mass of empirical data. So if people want to argue with me about that, they'll need to look at that data and find things that they think are more importantly different from it. But effectively, I have both research experience and, if you like, in-person experience of what happens to people when they have to rely on one or other hemisphere. And a very coherent picture comes forward. And it's based on the kind of attention that each hemisphere pays. Now, that might be relevant, it seems to me, because each kind of attention it's looking at the same world, if you like, but it's seeing something different in that world. So we evoke certain things from a mass of potential, which is that other that is outside of me and is not simply created by me. My attention evokes things from it, and in other words, the two come to meet. And that evocation, if I can put it that way, depends on the nature of our attention. So I think that what happens is, and this gets to the core thing that I think that Donald and I might disagree on, which is that I agree with him that our knowledge of whatever we like to call reality is never certain and never perfect and whole. That goes without saying. But there is a difference between a falling away from that whole truth that can be conceived in two different ways. One is that what I see is absolutely real, but it's only part of the story. And that goes with everything I know about hemisphere differences, that in a way each hemisphere sees something that, yes, has an argument to be taken seriously as an aspect of what is there. I mean, although unfortunately they're not equal in this, the right hemisphere is a much better guide to reality than the left. But nonetheless, what they're seeing is it's not that they're up against a wall, as in Kant. They're not sort of at one remove from the transcendent ideal. They are actually reaching part of it, but only part of it. Whereas you may correct me, Donald, but I have picked up, and I may have got this completely wrong, that you are holding out a vision that we are really always fully not connecting with that reality. What we're connecting with is a figment that we have made up, but it has nothing of, or very little of, or no, I think, aspect of reality to it. It is simply a representation. Now, the reason I'm interested in that is that, again, one of the big differences between the two cerebral hemispheres is that the right hemisphere is, as I say, experiential in a rather, I'm using that in a special sense, in that it brings to us the presence of whatever is. If you like, it's not just that it sees our presence, but whatever it is actively presences to the right hemisphere, to use a Heideggerian term. Whereas the left hemisphere sees a representation, which is literally something that is said to be present when it's no longer present. And I believe the left hemisphere deals in these replicas, diagrams, schema, theories, abstract time and space free constructs, whereas the right hemisphere is actually seeing something of what really exists, and that when we see a sunset, it is not more real to describe the neurons in the optic pathway seeing light with a certain wavelength and so forth. That is another way of thinking about it. But it is not more real than the sunset, as Whitehead himself argued. So that would be my position.
Very good. Well, I think, again, we're probably not that far apart. It's more a matter of the languages that we use. So the first, I couldn't agree more about the importance of relationships, and that it's relationships in some sense among these different observers and their interactions that's really the central point. And so the logic that I was mentioning is actually a logic of relationships. So I can say just a little bit more about that. So these observers all have experiences that, each observer has its own set of, and this observer might have 1 billion experiences, that one has 5 trillion, this one has 3. And so there's all sorts of observers with a whole range of experiences. The logic ties them all together. It shows the relationship among them. It's a non-Boolean logic. So, which is really quite interesting. So there's an infinite number of these observers, and the range of experiences is from 1 to infinity. And it's a very complex logic, but it's locally Boolean. So if I take one observer that has 5 quadrillion experiences, and I look at all the observers that are traces of it. So this is a technical term in Markov theory. If I take a matrix, say that's like a 10 by 10 matrix for, say, 10 colors that I can see, red, green, blue, yellow, and so forth. And it's just describing how these 10 colors change in my experience. And then I pay only attention to, say, 3 of the colors. So here's an observer that can only see red, green, and blue, can't see all 10 of them. The 10 by 10 matrix will induce a specific 3 by 3 matrix on the 3 colors that observer, the 3 by 3 can see, right? The 3. And it's called the trace. So if you give me a matrix on the 10 by 10, there is in general, a unique matrix on the 3 by 3 that explains what that observer will see, okay? And so that's called the trace. And so it's a different notion of trace than most people think of as, which is the sum of the diagonal elements of a matrix. So I'm just going to be very, very clear. It's not the sum of the diagonal elements. It's this more complicated thing. You literally have to look at the entire dynamics of the Markov system and look at there's an infinite number of paths you have to look at to actually figure out what the 3 by 3 matrix is, that is the trace. But it turns out that the relationship of trace is a partial order. That's the technical result. The trace relationship among observers is a partial order, and it gives you a logic, and it tells you how the relationships among conscious observers. It literally tells you which conscious observers have compatible points of view, which ones do not. If they're compatible, how they can actually join, how they could actually, 2 special, completely different observers that have different sets of experiences, but maybe overlap on a few experiences. If they're compatible, the mathematics tells you exactly how they can join to make a new observer that combines both of their experiences, or to take their intersection. So it's literally a logic of relationships among conscious observers. And so that's the first thing. So I agree with you on the relationship side of things. And where this goes, then, it's that logic that turns out to be, that gives rise to special relativistic effects. So I'll just give you an intuition about it. What we do with these Markov chains is we do a trick that's common in Markov theory. You go back decades, they add a counter to your Markov chain. So every time the observer or the Markov system changes the state, changes the experience, you just increment your counter. That's very, very simple. So you just have a counter. So it's not really time in the physics sense. It's just an arbitrary sequence counter. And if you notice, if I have my 10 by 10 matrix for a bunch of colors, and every time I see a new color, I just increment my counter. Now look at my 3 by 3, and that observer only increments when it sees red, green, or blue. It doesn't increment to all the other. So what's going to happen is the counter for the 3 by 3 is not going to be going as fast as the counter for the 10 by 10. And so it turns out when you do the math and you look at it carefully, that gives you time dilation exactly in special relativity for a certain class of Markov chains called n cycles. And for that, then the other thing is the relationship among experiences. So you can actually say, what is, quote unquote, the distance between, say, red and green? And it turns out that problem was solved, again, by Markov mathematicians only in 2017. So Doyle and Steiner proved that the correct way to do this is to say that the distance between two experiences is the square root of what's called the commute time. How many steps on do you expect to take from, say, red to get to green and then back to red in the whole Markov dynamics? So on average, how many steps will you take? If I have a red experience now, on average, how long will it be before I get a green experience? And then how long will it be to get back to a red experience? You take that's expected counter, that turns out to be the square of the Euclidean distance. And when you do that, you actually put, for a certain class of Markov chains, you actually get special relativity exactly. So you get special relativity coming out of the relationships among observers, conscious observers, directly. So it's in that sense that I'm trying to start with the relationships among observers and then show that certain properties of spacetime, Einstein's spacetime, are encoding these relationships. And that's why certain observers, like if you're on a train, you're going past me quickly, then Einstein says, if I look at your clock looks like it's going slow to me, and your meter, but my clock looks slow to you, and my meter stick looks short to you. So it's symmetric, and it turns out we get exactly this symmetry. But so where we agree is I'm saying we should have a theory of relationships among consciousnesses. And when we do that precisely, then it turns out I can give you, for a subset of these Markov chains, not all of them, but for a specific subset, we get Einstein's theory of special relativity. For a larger set, I believe we'll get general, and then for an even larger set, I will say, these are conscious relationships that cannot be in any way encoded in even Einstein's curved spacetime. And so I'm now countenancing the idea of headsets, so to speak, relationships among conscious observers that could not even be at all shoehorned into any kind of space-time at all. And so there's an infinite number of these.
Don, can we just clarify the concept of conscious agents? Obviously, a huge part of the theory rests on this. What exactly is a conscious agent? Like, am I a conscious agent? Are you one? And is there an element of a conscious agent that is outside of space-time? Because to me, that seems very, very significant.
That's right. So the first thing is they're not inside space-time. Conscious agents are entirely outside space-time. But space-time is one useful interface that some conscious agents can use to represent their interactions with other conscious agents. But it turns out that when we look at the set of all possible conscious agents, which intuitively all they are in this case are they have the ability to have a range of experiences, and then there are certain actions that they can take based on those experiences. And we can go into the actions if you want, but that's it. You have experiences, and you make certain actions based on those experiences. And so Nile is a well, what I see of Nile is just my headset representation of Nile. But what I think I'm interacting with is a consciousness that can act. So with a conscious agent, I'm only seeing right. Like you don't see everything about Don Hoffman. I don't see everything about Nile. I see my projection on my set of experiences of Nile, and so there is some overlap, and I get my picture of Nile. But as soon as I close my eyes, that's gone. But I believe Nile is still there. My picture of Nile was just gone when I closed my eyes, but Nile is still there. And so that's what an agent is.
I'm puzzled because I thought you said earlier that when you don't see things, they disappear.
So my experience of Nile disappears, but I think that Nile's consciousness is independent of me. But so I would say
that's a much more, yeah, okay, yeah.
So I'll put it this way. This bottle. Let's see. You can't even see it here. Okay. Maybe a cup. Yeah, there you go. The cup work. So the cup that you see is just some pixels on the screen right now, right? And now that's gone, right? Now you don't see them. Now, in some sense, you say, well, there's still a cup there, and yeah, but the cup that I experience is just my headset representation of the cup, and as soon as I look away, that doesn't exist. There is something that exists. But my experience is something inside space and time, and that space time experience is not fundamental. That's my experience. Whatever reality is, it gets projected into my experience, like we're playing a VR game, right? Like Grand Theft Auto, and I see you driving a car. When I see the car that you're driving a Jaguar. Then I'm rendering it on the fly, but in the computer, there's no Jaguar, right? There's just bits and voltages and so forth. So I'm rendering the Jaguar on the fly as I play, and then I no longer render it. And so it's in that sense that I say the cup doesn't exist. I'm no longer rendering the cup. There is something that exists, but it's utterly, as far as I know, utterly unlike my cup that I'm experiencing now.
Well, yes. But what would that be? What would it be that was more real than anyone's experience of something? It seems to me that you can't get behind that to something, even if you mention measurements taken in a lab and all the rest. They are still dependent on a consciousness that has sensory experiences and understands what they mean, and what we bring, as it were, to the party is something that can't be taken out without reducing it to a bit of a nonsense, it seems to me. I'm worried that this conversation seems to have gone into a space, a Markov space, where a lot of people's understanding of consciousness would be hardly present. I'm thinking about the consciousness that experiences love and experiences being a parent and experiences, everyday pleasures and friendship and it responds to works of art and so on. And this idea of consciousness seems to me to take us to somewhere very real. The relationship between consciousnesses that matters to me is the relationship between between two people, whoever they may be, and what each of them may give to the other. And as much as what you talk about is fascinating, it doesn't seem to me to illuminate whether there is reality in my experience of my partner, my friend, the garden, the mountain, the sunlight or whatever. And I think there's a danger that this theory tends to make everything terrifically abstract. in the belief that by making it more abstract, it's making it more real. Now, that is, in my terms, exactly what the left hemisphere would do. It would say, what this really is an abstract set of shapes and so on, and I can produce equations about them and so on. But this is not experience.
Very good. So this, again, I think raises a key point about the nature of scientific theories, right? So just stepping back to what we're doing for making scientific theories. On one aspect of it is the phenomenology, where we do experiments and we try to just look. And we look and we gather data, and Darwin did that, for example, and he came up with this wonderful, beautiful theory about evolution. He didn't use any mathematics himself. I mean, he wasn't a mathematician, but his insights really sort of were very penetrating and very, very powerful. And then John Maynard Smith comes along, quite a few years later, and takes Darwin's ideas and says, oh, you know what? There is a mathematical structure to Darwin's ideas. And so we get evolutionary game theory. And so it's Darwin's beautiful insights and real world interactions with animals and seeing what they do. And Maynard Smith then says, but you know what? We can get a lot of power here from Darwin's insights if we turn it into mathematics and then use mathematics. We can actually prove theorems. And so all of a sudden now we get this incredible power that we take Darwin's personal experiences. And so that's what I'm trying to do here. I don't want to run away from the reality of personal experiences and so forth. Absolutely, we should do psychiatry, we should do psychology and so forth. But at some point, we get all these insights, and the power of science then lies in taking those insights and saying, you know what, there's this mathematical structure that really captures what these insights are. And if we use that mathematics, then all of a sudden we can prove these things that we didn't even. So it's about the nature of how. So I agree with you. We should of course have the personal and the conscious and human relationships at the foundation, but then science does the math as well.
Yeah, I think that's the point. That the other, which can easily seem like a shoddy second, is actually the foundation of our experience of reality. And of course, what the left hemisphere wants is to be able to use this. And quite rightly, as you said, Darwin's theory became more useful when it could be operationalized in mathematical structures. And, it interests me, it's not just Darwin, but Niels Bohr, his notebooks contain no equations or anything of the kind. They just contain drawings. And so he was seeing what I call gestalten. He was seeing forms that were cohesive wholes that couldn't be taken apart without loss of something essential in them. So I think, indeed, from the accounts of great scientists and mathematicians, most of them work in this way of seeing something that is highly generative and evocative as a form. And in Einstein's case, it often came to him while playing music. So it was these forms that see, music is a very interesting case, because music could be seen as and can be represented on a sheet of paper as a lot of notes and that's what it is. And of course there is a score of any great piece of music, and it's as it were is that the gold standard? From one point of view, it is, but it's actually nothing. There isn't a Platonic perfect performance of Mozart's G minor quintet that everybody hereafter has tried to approximate. Every time somebody plays it, it lives again new through the encounter between those people and this guiding shape. And that doesn't mean, of course, that people can do what they like. Of course they can't. There's a very narrow range of possible performances that count as an authentic performance. But what matters about them is often something that is very hard to enumerate or even to express in words. And you can feel it. And, perhaps a certain kind of musical scholar might be able to say, well, it's because of X, Y, and Z. But we're all the time experiencing things in different ways. And I think that what we're experiencing is something real. It's not something in which we're cut off from reality, reading out on dials, which is the image that you sometimes use and that slightly troubles me, that it's a readout from a bank of dials, like a pilot in a cockpit. But I think this pilot is always looking out as well, and is guided sometimes by these things, but is actually flying somewhere in real time and space. And so I wonder if you would say something about that, whether you think that the idea of reading from a bank of dials is taking us too far away from embodied and embedded experience, words that I find very important. That the best and most important things about our lives and our experience are that they are embodied and they are embedded in a culture, in a place, and a time. And the drift of this conversation has gone very far to an extremely abstract place, which is fine, but I'm not sure that it's necessarily the place where truth resides.
I agree. I think our lived experiences are the foundation, and they're the central point. And we do just fine in our everyday life without the mathematics. But what happens in science is, for example, Faraday did all these beautiful, clean experiments with magnets and electricity and so forth, and just incredible first person experience with all these things, and then Maxwell comes along and looks at the results, and he writes down some equations. And the reason we can do this Zoom talk is because of those equations. And without those equations, there would be no chance for us to have this connection. And so here we see the absolute interplay, right? Without the mathematics, we wouldn't connect right now. So it's a weird kind of back and forth. So there's the very...
But I think we need the back and forth.
Yeah, they go back and forth.
Yeah. But no, I don't deny that at all. I mean, of course, I'm not saying that maths is not both important and beautiful and has a kind of truth. It's a wonderful thing. And of course, its practical applications are things that, as a doctor for a lot of my life, I've found extremely important. So I think about all that we agree. But it's just this idea that there might be something more real that is completely unknowable and behind a screen or a wall. I think no. I think that we really do experience what we think we experience when we smell mint or taste pineapple, as you say. We really are. These are the real thing. And I think you do say that somewhere, because I think I quote it, that it's the real deal. This is the real coinage, the coin of the realm, the true coin of the realm, when we have these experiences.
Okay, so that's a very, very important point. And so I'll say absolutely, the experiences are real experiences, and they're sort of the coin of the realm. But there's another aspect to this that I think we probably will agree on as well, and that is any theory has finite scope. And there's an infinite, so no matter what we say, no matter what description we give, we're either giving a rigorous theory or an informal theory, but we're giving a theory. Most of our theories are informal. And ultimately, whatever reality is, infinitely transcends anything that we can say. That I suspect we agree on that. So who Iain is transcends anything that Hoffman can say and anything that Iain can say. And ultimately, even my description of my experiences are just descriptions of my experiences, and whatever I am transcends that infinitely. So what I see going on here is, I don't want to deny that the experiences are real, and I can talk about them, but then I want to say that there's a reality that infinitely transcends it that I can't even talk about, because it's much, much deeper than language could ever go. But the role of mathematics then is to say, not that I'm getting the mathematics, so therefore I've got the truth. No, I'm giving you another description. But the interesting thing about this description is it's precise enough that you can actually find out more easily where I'm wrong or my limits are. And you can also build stuff with it. What's the magic to me is that Maxwell's equations let us do this. That is, even though they're not the final truth, somehow they're giving us a hook about how to interact with each other that we would not have otherwise. And yet I'll be willing to say Maxwell's equations do not describe the truth. And yet, without those, so this is where I find myself. Reality is really interesting. Change one number in Maxwell's equations, this whole thing goes down. The whole thing doesn't work. So on the one hand, we should have these intuitive, feeling kinds of things. And on the other hand, reality also says, you get wrong in the 10th decimal place, this whole thing goes down in flames. To put those two things together, that's really, and yet reality transcends even that.
That's right. And I have argued at length in both the Master in Telemetry and the Matter with Things, that language is a practical tool originally for enabling us to talk about something that's not present in front of us. And so it's not designed that it should have the capacity to deal with everything we experience. So I completely agree that a lot of experience is beyond language, but it is also beyond scientific demonstration or even scientific capture. And it's also beyond rational discourse. Now, that is not to disrespect either science or reason. I'm a great fan of both of them. I hope I use them in my work to advantage. And I often find myself having to defend them against their detractors these days, because some people, for political reasons, don't like science and reason because of the conclusions that they come to. So I'm adamant that I value them. But I also believe that beyond this, there are two very important other paths towards the experience of reality. One of them is, and you just mentioned it, intuition. And the other is imagination. And of course, they can be mistaken. But then actually, so can reason and so can science. Science can, in one way, be described as the pursuit of the perpetually mistaken, because science is always moving onwards, thank goodness. That's the wonderful thing about it. And so what was true yesterday in science is not true today, and so forth. And reason, there's lots of things that are not irrational in the sense that they defy reason, but are just beyond the scope of reason. For example, a great Bach cantata. It's not irrational. It's just trans-rational. And there's a lot of experience that is like this. I'd say love is like this, sex is like this, friendship is like it. I'd say that art and music and architecture and painting and myth and faith and narrative, all these things have their uses. They are able to bring to us things that otherwise we would not reach by a much more narrow path. And those paths are not narrow in a bad way. They must have their presumptions, as you say at the outset, their axioms on which they're based, and they must say, for these purposes, we are not going to include, for example, purpose or ideals or anything like that. We're just going to look at mechanisms, and that's perfectly good. I'm not against it. What I am against is people coming back from those expeditions and say, "Oh, we found no purpose and we found no value." Well, of course, you can't claim that because you didn't even look for them and you cut them out of what you were going to allow yourself to find. So we need a number of different paths, and I'm just putting in a word here for how I think personally I have intuited things that I believe to be, I may of course be entirely mistaken, to be entirely real. And what gives me some hope is that lots of people I consider both intelligent and wise over the years have also thought them. And they can't be demonstrated by science or reason, but they are nonetheless very real. And that that we can't actually understand anything, even in science, even in mathematics, without having a degree of imagination. And all the great scientists and mathematicians talk about this in coming to their conclusions. So I'm just trying to, say, I don't think reality can be reached by any one single path. But I think that if we bring together reason and science with intuition and imagination, we have the best shot we can. And at times we'll need to go beyond what any one of them is capable of. We will want to set limits or we will want to break those limits. But those four pathways give some traction on finding out what is real.
I completely agree. I think we're exactly on the same page. And in fact, I would say that in some sense, the closest I get to reality is when I let go of every thought and just go into complete silence. And that's often where the insights come. I will do all my homework and read and so forth. And then I go and spend an hour, like, just the whole point is no thoughts whatsoever, nothing, literally nothing. And I think that's the closest I get to embracing the ultimate nature of reality, which many wisdom traditions have said for thousands of years.
They have. And I think that's because we can't grasp reality by going for it. We have to allow reality to declare itself to us. And the only way we'll have space and time to do that is if we stop crowding it out with our own thoughts and our own knowledge and so on. And this is why in the Eastern tradition, there is an unknowing that comes after knowing. It's not the same as ignorance. Ignorance is what you have before you know, but unknowing is what you have after you know. I'd like to put in a word for that. And yeah, and I think that, silence and listening and accepting and receiving is actually a very wise thing to espouse. Yeah.
I completely agree. And what's miraculous to me is that you come back from that space and you come back with ideas. And then I'm not a mathematician. I work with Chetan and other mathematicians. I'm mostly intuitive. I know enough mathematics to get in trouble, but not enough to get out of trouble. And so I work with real mathematicians. But what stuns me is I know that the mathematically right down is not the final theory. It's nowhere near the final theory. And yet, if you change Maxwell's equations, this won't work. So even though the math seems to be a more or less accurate description of a perspective on reality, not of reality itself. This is the closest I can get. But there are perspectives on reality, and for those perspectives, then the mathematics better be right to the 20th decimal place, or you're wrong about that perspective and it won't work. But as soon as you change perspective, now Maxwell's equations won't even hold because you're now in a different perspective. And that's the best I can come up with. And I don't know if it's good enough.
No, I like that.
I figured we were on the same page pretty much, but that it was just a matter of the language that we use. That was my guess.
No, that's right. And I think it's been great clarifying that. And I worried we would be so much on the same page we'd have nothing to say to one another. But I think we have, and so that's all been good. Yes,
absolutely.
Yeah, yes, we've in that phrase of T.S. Eliot's, we've come back to the place where our journey started and know it for the first time. So that's very good.
Well, this has been a fascinating conversation, guys. You've made my job very easy. Where would you send people after this conversation to learn more about your work? So, Iain, your website, channelmcgilchrist.com?
Yes, I think that's a good place to go. Most of the material there is accessible to any casual caller. You don't have to sign up or pay. And obviously my major works are The Master and His Emissary and The Matter with Things. But there is also a little ebook which you can get for less than $1 sent to your mobile phone called The Divided Brain. Why Are We So Unhappy? I think it's called. And it's 30 pages. And of course, it can't condense 2,000 pages, but it gives you some provocative and I hope evocative ideas.
Well, I've got a couple of books. The Case Against Reality is one, and another one is Visual Intelligence: How We Create What We See. And then I do lots of podcasts. If you just Google Donald Hoffman podcasts, I've got dozens of them. There's a TED Talk and so forth. So, yeah.
Yeah, you guys are everywhere. You really are. Okay, we'll end it there. Thanks so much, and we'll talk soon.
Thanks very much, Niall.
Great pleasure, Iain.
Great to see you. Yeah,
absolutely.
If you enjoyed this episode, you might also enjoy getting our 7 Insights newsletter. This is a once per month email where I share 7 of the most valuable insights I've uncovered in the previous 30 days. It includes book, podcast, and documentary recommendations, as well as questions and quotes specifically curated to help you live a more creative, intentional, and meaningful life. It currently goes out to over 50,000 subscribers each month. And if you're interested in joining them, you can sign up via the link in the description.